SwayamPrabha. Digital India. Educated India.
Welcome back. In module 2 we will cover urban water supply, and in lecture 6 we will look into water demand prediction and management. So the different concepts that will be covered in this lecture are water demand and key issues, urban water demand forecasting, urban water demand and natural systems, spatial and temporal patterns of water demand, and some methodological advances. So, when we talk about the different issues that is plaguing the water supply in general and also water estimation of water demand, climate change and population growth are the two key issues that are really which are putting all scientists as well as urban planners. It's the biggest concern for them, and as a result of climate change, we are likely to see billions of people being affected. For example, freshwater availability in Central, South, East and Southeast Asia, and particularly in the larger river basins, are projected to decrease. And this is going to affect, by 2050, it is going to affect around 1 billion people. And as you know, India is one of the countries which is not only at the equator, plus also we depend on the lot of glacier fed rivers. In that case, India is going to be one of the most affected countries, and in a recent event you have seen that the Rishi Ganga river, there was an event where due to glacier melt, a lot of water came down, and the dams and bridges, everything was broken or washed away along its way. And this is going to create a lot of problems in future as well. And so glacier melt in Himalayas is increasing because of climate change, and because of this melting of glaciers, there is going to be increased flooding, rock avalanches, and also it's going to affect the water resources, because if we cannot trap the water in our dams and all, we would not be able to use those water. So, in addition to climate change, the other bigger change is of course lifestyle change and population growth. Particularly in India, we are going through a lot of economic changes, and that's also changing our lifestyle. Due to a huge population growth as well, this is also increasing the pressure on or increasing the demand of water in urban areas. So, IPCC, the Intergovernmental Panel on Climate Change, they estimate that the per capita freshwater availability in India is going to reduce drastically to around 1140 cubic meters per year in 2050. Compared to 1820 cubic meters per year as was in the year 2001. So, you can understand that it's a drastic reduction, and so our government is also very, very concerned about this. So, this map that you see, this is the water risk map, and this is prepared by the World Resource Institute, and as you can see that over here we actually different kind of risk. It could be because of physical quantity of water available, it could be about the quality of water available, or it could be about the different regulatory and the reputational risk categories, like for example, how good are the institutions in managing water, and all these things actually play a role in determining which are the most riskiest areas in the world. And as you can see, Africa, large parts of Africa and Asia is are at very high risk category, and particularly India is at severe risk category, right. So, that you can see that entire India is very dark red, which is extremely high and also high. So, this is what is the situation in India, and we need to be very, very aware of it. So, the first thing that we need to do is to understand how much water is required in the future, right, and for that we have to do urban water demand forecasting. Now, urban water demand actually it's the water resource management, that means the overall water that is available in a particular area or a particular country, it's a resource and we have to manage this resource. And if we don't manage this resource, it will impact the environment, it impacts the food production of that country, it impacts the irrigation, it impacts the energy balance. A lot of energy production also happens along this particular river. Using dams and all, we can also trap water and use the water for production of energy. Sewage treatment, urban water consumption, everything is affected because if we don't manage our water properly. And water resource distribution includes both the consumption of it and the collection part, the distribution part, the consumption part, and finally once it is consumed, the wastewater is collected, and then the treatment part. So the entire chain is actually being affected if we don't do proper water resource management. So what's the need for demand forecasting? There are different purposes, of course, but the first thing is we want to estimate the future consumption of water. And if we do that, and we want to do it accurately, and if we do that, it reduces the cost and also increases the reliability, right? For example, if we don't estimate the demand correctly, then we may end up with preparation of a wrong infrastructure, or we may execute a wrong infrastructure which needs to be modified in future. That will increase cost. And obviously, if we know exactly how much water is going to be available at certain time periods, at a certain year or during certain seasons, then of course it's reliable and we can use the data to work further to make sure that we can make up those gaps or the deficits and so on. Then we also can identify which are the factors which are affecting the dynamics of water usage. So which are the factors that influence water usage or water consumption, and if there is a chance of changing or introducing certain policies to bring a change in those factors so that it will reduce water usage. Then optimizing provision, design and operations of water supply infrastructure such as the distribution network, pumps, reservoirs, power usage and so on. So basically, when we design the entire water supply network, starting from the pipelines that takes the water from the treatment to the overhead reservoirs to the different buildings, the pumps that are required in the system to pump water, the storage reservoirs, the size of those, right, and the different power required to run all this infrastructure. So these are the different things that needs to be, we have to rightly size. We have to determine what size of pipelines, what horsepower of pump, this has to be determined, right. So we have to optimize that. So if we know the exact amount of water that needs to be supplied based on availability and so on, so that because we know that based on the demand that is there for a particular urban area, we would be able to design this system in a much better way. And then, because as we already discussed, water is gradually getting scarce, and because scarce resources, that commands larger price, right. If a certain quantity is scarce, then we have to ask more price for it, right. The price increases. So that is also going to be a big issue in future. And finally, accurate estimate of peak water demand is required. The peak demand is required because the infrastructure is more or less, the pipe networks and all is designed based on the peak water demand, right. So these are the different reasons we need to do proper forecasting of demand of water for urban areas. Then there could be two kinds of forecast. One is a short term forecast and then there is a long term forecast. Short term forecast usually is used for different operation and management, whereas long term forecasts are used for planning and infrastructure design. So that because long term forecast, like the next 20 years, 30 years, what kind of demand would be there. So this is a long term forecast, and this is required because infrastructure life varies from around 25, 30 or even more than that, right. So many years, right. So we design infrastructure which would be there for 30 years. So we have to also know what kind of demand would be there for 30 years down the line. Whereas short term focused are mostly for operation and management, like demand fluctuations during different time periods and so on, right. So these are the different things that we need to understand. So in addition to this forecast, we also need to understand the variability in the demand. That means because of climate change, there are certain unpredictability that has also come in, that suddenly certain events happen which we cannot predict. So these are the things that we also will try to look into, and then also the natural variation. So some of this variance is because of the natural cycles. Sometimes there is higher rainfall, sometimes there is lower rainfall, but some of it is because of climate change. So that also needs to be understood. So, we know that sustainable levels of water withdrawals, that means because a lot of water is being now used from the groundwater, that means in addition to surface water sources, we use a lot of groundwater sources, and actually the amount of groundwater sources is higher. And so, this surface, this water that is withdrawal from the groundwater sources, and if we cannot control it, that means then it will lead to other problems. So, we will talk about that in later lectures, but if we can control it, then it leads to large scale water use efficiency. So, that means we can efficiently use the water, and we can again reuse that, we can again keep on extracting it in a sustainable manner, right. Then while water price, income and household composition determines residential composition, water demand is mostly inelastic in terms of water price. So, the amount of water price, income of a particular household and the household size, this determines the amount of water that is consumed by that household, right. But at the same time, we have seen that if I change the price of water by a certain margin, it is largely inelastic. That means, even though we change the price of water, we expect that people will consume less water, but usually it is not so, right. So, that is why we call it that water demand is mostly inelastic in terms of water price. Then personal characteristics and behavior, that means individuals' personal characteristics and behavior, such as attitudinal factors, their beliefs, their habits, their routines and personal capabilities, these also affect the demand side management and also affect the adoption of different conservation techniques and strategies. That means, there are certain people who are they will like to conserve water, and other people will say I do not care, right. So, this depends on the attitudinal factors, the beliefs, the habits of those particular individuals. So, this is again plays a big role. And finally, major physical and the different other factors which actually play a large role in determining the domestic water use, how much water will be consumed, is climate for that particular area, the economy, that means how well off that particular area is, the urban design of that particular area, and the demographic characteristics of that area. So, domestic water use, even though it is for individuals use the water, but when we say domestic water use, it is referred to for the entire urban area. So, in an urban area, the amount of domestic water use varies as per its climate, the economy, the urban design that is you can see in that particular area, and the demographics. Because urban design, how does it affect? Like for example, in one urban local body, they may have used a lot of water for beautification. So, there would be more demand for water, and in general more affluent societies will use lawns and all these things. So, they will require more water. So, that is how different economy and all plays a role in determining the total amount of water. So, urban demand is also linked with the natural system. That means, what is the natural system? Natural system is like the rainfall that is generated, the amount of water that percolates inside the ground, it becomes groundwater, again it is extracted. So, this and then some of water goes back into the streams. So, this is the overall way the natural system works, and so groundwater demand depends on the natural system as well. So, that means availability of groundwater and what kind of drought, or if it's a if it's a good rainy season is happened in that particular area. So, all this will affect the urban water demand. And in addition, we also look into the spatial and temporal patterns of water usage. And why we need to do that? Because this will vary as per the different urban area, and if we know that, then we know why this variation happens and where this variation happens, right. So, some areas the pattern will not be same in all areas. So, in different urban areas the patterns will be different, maybe based on different demographic urban design characteristics of those area. So, but that needs to be ascertained. So, if we summarize, we can say that long term changes like population growth, income growth of an area affect water demand slowly. Climatic factors such as temperature, precipitation, evapotranspiration, this results in seasonal fluctuations. That means, in summer water requirement is higher, rainy season water requirement is lower, or you can see for even winter sometimes the water demand is again higher. So, rainfall, heat waves, etc., result in immediate fluctuations. So, these are the three kinds of demand and its fluctuations that we need to be aware of. Now, when we talk about urban water demand and natural systems, we say that this actually is basically the interaction between humans and natural systems in urban areas, right. So, there are a lot of micro scale interactions. That means, in an urban area, individual households or at a building, people in a building or in a parcel means a group of buildings maybe. So, there people actually consume water and they actually take different decisions, right. Some will consume more, some will consume less, depends on many things, depends on if they have a lawn, depends on if they have a swimming pool and so on, right. So, this micro scale interactions actually affect the overall macro scale, which is the municipal or regional processes and patterns of water use, right. So, individual uses sum up and they affect the overall processes and patterns in an urban area, right. So, this overall patterns and some people, so we can find both the micro scale interactions. From there we can try to generate the macro scale patterns and all, or we can actually investigate the macro scale patterns as well. But this macro scale processes and patterns, as you can understand, this looks for a larger area. So, automatically we have to look into the different urban hydrological processes and different activities that are happening. That means, how much water is recharged in this particular urban area, what kind of built up area, what percentage of this area is built up. Based on that, we can determine the amount of runoff, and all these things needs to be looked into. So, water demand is thus linked to urban hydrological processes, and we need to model it as well. So, what kind of models? We look into catchment processes, we look into floods and drought forecasting, we look into water resource planning, climate change risk assessment, human impact on hydrological systems. So, these are the different aspects that usually hydrologists study, and sometimes urban planners also look into certain aspects of it, not everything, but some parts of it. Now, let us look at the different kind of effects that individuals actually that actually affects the behavior of individuals. For example, droughts or floods that actually affects micro scale interactions of individuals. Like, for example, households' ownership of water consuming appliances. If the household buys appliances which are doesn't use that much water, or sustainable, more water friendly appliances, then it will reduce the water content. If the household has got a lawn or garden and they prefer to have lawns or gardens, or if they want to invest in some conservation measures, that like rainwater harvesting and all in their particular building. So, this is also impacts the overall demand for that urban area. Then, in addition to that, it also depends on the soil type of that area, evapotranspiration rates, vegetations that is there in that particular area, and it depends again on human preferences, because humans are the ones who choose what kind of vegetations to plant there and so on, right. So, to give you some examples, the yearly demand in Phoenix, Arizona, this is in US, it was found that about 1% change in houses with pools, addition of houses with pools, 1% change actually resulted in 1% increase in yearly water demand. Then 10% decrease in precipitation. So, this is a lifestyle choice, right. So, this one is a lifestyle choice. Then 10% decrease in precipitation led to 3.9% increase in per capita demand. So, this is where you can see that some amount of this natural systems actually is playing a role. 10% decrease in precipitation actually increases the chance of increases water consumption, and 1 degree centigrade increase in annual temperature resulted in 6.6% increase in per capita demand. So, these are the different things. This is how you can see the natural cycle or the natural systems are actually linked with the water demand as well. So, when we look into the spatial and temporal patterns of water demand, so this is we already discussed that we need to investigate how temporarily at different time periods or at different zones, how the water demand varies in an urban area. So, we see that the daily and monthly demand forecast could be done using multiple regression and time series analysis to determine the supply infrastructure. So, that means we can do this kind of predictions using this regression models. Now, what is a regression model? Regression model is where we have a set of explanatory variables and we have a decision variables. In this case, the decision variable is the amount of water that is consumed. It could be either per capita water consumed, it could be a total water consumed for that particular area. And it is actually being predicted by many factors, depends on the climate of the area, the soil type of the area, depends on the income pattern of the income of that particular individuals staying over there, and many other factors could actually influence the per capita consumption in that particular area, right. So, that is how multiple regression models can help, and time series analysis can also help, where we can also analyze these changes over a time period as well. So, household, and so in addition to that, household data related to household characteristics such as income, household size, and all the other things also has to be understood, or also has to be there, so that we can predict that okay, how households, different kinds of households consume different kinds of water, different amounts, volumes of water, and from that we can also derive certain relationships. And spatially explicit patterns of water demand is also investigated to understand effect of local scale human and natural processes on water consumption. So, this is where we are talking about the spatial variation of water demand, and because local scale human and natural processes for that particular urban area actually influences the demand for that particular area. So, of course, it varies spatially. So, these are the different things that is looked into, and when we talk about the different explanatory variables for this regression, there could be some variables which are mostly related with the temporal changes, there could be some variables which are related with the spatial changes, and we can use both of them together to predict the future water demand in a particular area for a particular time period. Right. So, let us see which are the variables that actually are used, like these are the variables like temperature, like we said that 1 degree increase in temperature increase the per capita demand by a certain percentage, right. So, wind speed of that area, right, that also influences water consumption, water price, population growth, income, rate structure, the pricing of water of that particular area, evapotranspiration, precipitation rate. Sometimes we already discussed that it is not, it is inelastic, but still some changes happen. For the spatial part, we look into the age profile, the education profile of that particular area, the household size, the distribution of household sizes in that area, what kind of race lives there, what kind of people live there, built up area percentage, number of bedrooms, outdoor area, pools, gardens, housing typology, NDVI. This is the vegetation index that you can determine for a particular how much amount of trees are there. Then urban heat islands, UHI. So, what is the urban heat island status for this particular area? So, these are the different parameters or variables which actually could be used to determine what is the likely demand for water in a particular area and for a particular time period. So, this is one case study from for a residential water demand model for Jaipur city in India, and you can see that over here the authors have used that ordinary least square regression, multiple regression model. If you are interested to learn multiple regression in detail, and you can follow this particular lecture. This is a lecture from one of my different courses. So, you can go into this link and you can find that particular lecture. So, there we have explained how to do a regression model. So, that you can actually look into. But here in this particular model, the residential water requirements for a densely populated area of Jaipur city has been predicted, and the explanatory variables used have been household income, age of respondents, household size, age of home, wealth, asset score. Asset score is relates to amount of different items that are there in the household. It may be TV, television, it could be refrigerator, and so many, because that actually is a that actually determines what kind of use of water could be there, or determines the overall affluence and so on. Then the dwelling status, monthly expenditure on water supply, number of bathrooms and number of rooms. So, these are the parameters this research has used, and they found that these 4 parameters, income, household size, expenditure on water supply and asset score, these were the 4 parameters which actually really determined residential water demand for this particular urban area. The other parameters were not found to be significant, or those were not having much of any influence. So, all of them has got positive signs, only one has got a negative signs. What it means is, if expenditure increases, then the demand decreases. That is why it is a negative sign. For everything else, if income increases, demand increases. So, it is a positive sign. Household size increases, demand increases, right. In this way, this has been done. So, this is one example. Now, coming to the different kinds of research that is done in this particular field and the different methodological advances, we can say that introduction of GIS actually has really influenced this particular field, and Government of India is also now looking into incorporate different remote sensing and GIS applications in this to determine water demand and so on. So, here because of GIS, different kinds of data, spatial data, social data, ecological and time series data, this could be linked to the household scale water consumption data. That means, in a map we can see that in a particular household how much amount of water is being consumed by that particular household, and we can link all this other data which are available from other data sets to this through GIS. Spatial statistics to determine patterns of clustering and dispersion. So, we can, because we are already want to know the spatially how things vary. So, using clustering and dispersion, we can determine that using spatial statistics in GIS. Spatial autocorrelation, this is like where you can understand that, okay, in a particular neighborhood of if one of those zones is little bit different from others, right, or it is showing similar patterns like everything else. So, this similar and dissimilar patterns could be also identified, and through spatial autocorrelation, and spatial regression and geographical weighted regression. So, this is regression, but here we have a little bit difference. That means, we do the regression for local areas, and we have for each area we have got explanatory variables which may remain same, but their variables will vary. So, or their coefficients will vary. So, the effect of different variables or the weight of different variables will vary in each of these local areas, right. So, this is how a geographically weighted regression is better than a standard regression. So, these are the different advances in terms of GIS. Then we have got integrated models, dynamic models we call them, dynamic because they can predict the changes that happens, like agent based models, ABMs, or system dynamics models, SDMs. So, these are the 2 kinds of modeling that is gradually being undertaken. System dynamics actually relates different kinds of relationship between different entities, different processes and all. So, if you change one, everything changes, and that could be tracked, because the use of water is not a straightforward thing. It is linked with many events, natural as well as man-made events, man-made processes and so on. So, if you change certain parameters, you see changes in all the other things, and it will show an overall change in maybe the water demand, right. So, this agent based models are similar, but it is where you have got different agents, and you can have multiple copies of those agents also interacting with each other, and some of these agents could be processes, some of these agents could be individuals, all of them interact in an urban area, and based on those interactions we can get the overall demand. So, this is a new way of modeling of demand. So, either we can go for regression, straightforward regression models, or we can go for this more advanced models for determining water demand. So, this allows a detailed estimation of social and natural system variables, and how the different processes are related with each other. And so, relationship between past and present, that's we can also relate with what changes happens in the past and what is changing in the future. So, how are this linked? So, that's why it's called a dynamic model. And we can also test different policy interventions, individual choices and climate change uncertainty into in this particular model. That means, if I change certain things, certain policies we take, what will be the effect on water demand. So, these are the things that could be also tested using this model, which is which some of it could be done using regression models, but not all of them would be that much possible through regression models. In addition, artificial intelligence methods are also coming in. If you are able to store if you have sensor data for different water moisture content or humidity patterns, weather temperature patterns and all. So, this data, if we can keep on stored for a long period, then when we do our regressions, instead of doing straightforward regression, we can go for artificial intelligence methods, where like we can use artificial neural networks, fuzzy inference systems and fuzzy neural networks. So, these are the different ways of predicting or determining total water demand in an urban area. So, of course, based on different explanatory variables. So, it is similar to regression, but it depends on patterns based on the existing data sets, right. So, these are the different methodological advances which are happening in this particular field of forecasting water demand. So, to conclude, climate change, population growth and water scarcity has increased the significance of water demand forecasting for urban areas. Water demand forecasting not only allows more accurate estimation of water consumption in future, but also allows us to identify relevant factors which could help in influencing the same. Water demand is linked to urban hydrological processes, which needs to be understood in detail. Then spatiotemporal patterns also needs to be investigated to understand effect of local scale human and natural processes on water consumption. And finally, new methodological advances has improved the accuracy and use of water demand forecast. So, these are the references you can use. Thank you.